Okay, number 4. We talked about this yesterday a little bit. If you have an x-intercept of 1, that means that you have the ordered pair 1, 0, y-intercept of 0, negative 3. I have my y-intercept. I just need to know my slope. So I found the slope between those 2 points to be 3. So now that I know this and I know my y-intercept, I can write the equation y equals 3x minus 3. Number 6, it says a line going through 1, 3 has a slope of 0. Okay, you have to think, okay, slope of 0, is that a vertical or horizontal? Horizontal. What type of equation is horizontal? Is x equals or y equals? Y equals. You cannot forget that, guys. And the way I remember it is opposite of what you think. The y-axis goes this way, but a horizontal line is y equals. And x-axis goes this way, but an x equal is this way, okay? You cannot forget that. All right, so a slope of 0, I know it's y, and you just put whatever number's in the y coordinate. Y equals 3, okay? Number 8, you need to know the slope and y-intercept. I know neither. So I found my slope to be negative 8. And then I found my y-intercept to be negative 11 using y equals mx plus b, okay? On your test on Friday, the back page will deal with these type of questions, okay? And the first 3 is just find the slope of these 2 points. Like on that last math workshop, we just had to find the slope between the 2 points. And then you have 4 situations like this on your test, okay? All right. Are there any questions on 4, 6, or 8? Okay. We did 10 yesterday. 12. It says it's 35, 1, slope of 0. That's y equals 1. It's a horizontal line. 14. Parallel to the x-axis. Well, the x-axis runs this way. If it's parallel, it will have to be horizontal. Does that make sense? So that's why it's a y equals 5. Okay? It's parallel. Alright, number 15. It says it goes through point 1, negative 6 and is parallel to line x plus 2y equals 6. Alright, we use this part to find the slope. And what do we know about parallel lines, guys? They have the same what? Slope. Very good. But can I pick my slope out right at this very moment? No, I need to get it in slope-intercept form. X plus 2y equals 6. 2y equals negative x plus 6. Divide everything by 2. Y equals negative 1/2 x plus 3. Alright. Now, my slope is what here? Negative 1/2. So I'm done with that part. I use that. So m equals negative 1/2. Now I'm going to use y equals mx plus b. My y is negative 6. My m is negative 1/2. Negative 6 equals negative 1/2 plus b. Move that over. That's going to give me negative 5 and 1/2. I'm going to change that to a mixed number because I just like mixed number. I mean, not mixed number, improper fraction. So it'll be negative 11 over 2. So y equals negative 1/2 x minus 11 over 2. Do y'all agree? Okay. Need some mischief. What if I left it negative 5 1/2? I'm not going to count that wrong, but it's not my preference, but that's fine. Are there any questions on that? We good? I need a hand signal. Okay, thank you. Alright, yes, Miss Trisha did this 2 days in a row, and that's a record. I worked all your homework out again. So take the moment while I post attendance to look at this. Check your homework. All right, looking at number 66, 70, 74, and 79, what type of equations are those? What type of equations are those? Okay, I'm going to ask that question again. What type of equations are those? Say it with confidence. What type? Factor is not a type of equation. That's a technique. What is it? Quadratic. We got to get our terminology. I'm big stickler on terminology. It's quadratic. And why is it quadratic?
Because of the square.
Square, because it has the exponent to it. Every lesson this year I'm going to ask you what's the name and why is it called that. So we need to know that, okay? All right. Before we go to this, so far what we covered is going to be on our test writer. Solving linear. How do we know something's a linear equation? Has the exponent, the greatest exponent is what? 1. Very good. Solve for a given variable. That means get it all by its what? Self. Solving quadratic, we just talked about that. We solve quadratic equations. They have the highest degree is 2. And we solve them by what techniques? What's our first technique? Derek? Factoring. If that doesn't work, then we use the what? Quadratic what? Formula. Very good. Alright? Then we're going to solve radical equations. And we know something's a radical equation because it has a what in it? Radical. Very good. And the goal of that is to isolate the radical on one side and get rid of it. Okay? And the last type thing that we talked about is solving rational. How do you know something is rational? It's in the form of a what? Fraction. Okay? And the first thing you're going to do is get rid of the what? Fraction. Is everybody good so far? Okay, you got to lively up. Because when we just go 2 or 3, that's going to put you to sleep and put me to sleep, okay? I got to have some energy in here, okay? Or you're going to hear the gavel a lot more. All right. So on 66, it is a quadratic, and I try factoring first. If factors, I'm good. 70, no matter which way, some of y'all do slide and divide, AC hard, bust them up, whatever, you should still arrive at the same answer. Okay, I do bust them up. 74 could be factored. I get the same thing in both parentheses. I only have to write one answer. You don't have to write 1/2 twice. Now, 79. 79 cannot be factored, so I'm forced to use the quadratic formula. I get down here, I got to try to break 56 down. There's my factor tree. Broke it down, took a 2 out. Then I looked, okay, what number can I take out of all 3 of those? That's a 2. That leaves an 8, a 1, and a 10. Are we good on quadratics? I need a hand signal. Everybody to your chest. Good, because you're about to do a checkpoint in just a second. Alright. Now, 89 and 91 are rational functions. Okay. First thing you do is you got to think of a common denominator. My common denominator is all 3 of those. So I multiply everything by those 3. Here, the x minus 1 cancel out. Here, the x plus 2. Here, the 4's cancel out. I'm left with 4 times 1 times that. 1 times 4 times that. 5 times that times that. Get down here, FOIL that out. Distribute the 5. It has went from a rational to a quadratic. So quadratic, I get set equal to 0. I factor it in my technique. Yours might be different because you do other techniques. But I arrive at this. Now, because I went from a rational to a quadratic, do I need to check to make sure that these answers do not make this undefined? Yes. Do either one of those answers make it undefined? So those are my solutions. Okay? Alright, 91. My common denominator is x minus 3. Alright, so I'm going to multiply everything by that. I'm so happy to say 0 because 0 times anything is a 0. 4 times this goes here. Negative 12 times x because those cancel out. These x's cancel out. I come up with a quadratic. Now, I want to bring your attention to this. When I get down here, 4x squared minus 14x minus 30, if you can take a GCF out there to help you bring those numbers down, you can do that, okay? I brought a 2 out. And when I brought a 2 out, it made the number smaller, didn't it? You can do that. It's legal, okay? And you don't have to really worry about that 2. Now, leave it there. But does it have a variable with it? No. So, now, I went over here and factored that 2x squared minus 7x minus 15. And I got these two factors. And that's what I put here. I set both of those equal to 0. I didn't have to worry about that 2 because, once again, it did not have a variable with it. So I got 5 and I got negative 3/2. I checked to see if either one of those makes that undefined. It does not, so both of those are my answers. Okay? Our rational equation making more sense with you today. Okay? We're going to practice them some more. I gave you 3 tonight to practice again to make sure. And they're going to be on a check point in a minute. Alright, 93 is easy. 95 was pretty easy. 97 was the more difficult of the 3. Okay, you're going to move that 1 over, pull that out. That's x squared minus 2x plus 1. It's quadratic. Bring both of them over here. That is not difference of squares because the x is not squared. It's just GCF. Okay, x equals 0, x equals 4. Since it went from a radical to a quadratic, you got to check both of them and make sure they're solutions. I plug 0 in. 0 does not equal whatever. This side does not equal that side. So 0's out. My only answer is 4. Okay. Are we good with that? Okay. Now, what we're about to do is check point. And this is how class is going to work the rest of the period, okay? It's not fast-paced like it has been the last few days. All right. So you have a check point, side equation. When you come up here, I only like 2 people at a time. So if 2 people's already up here, don't form a line out the door. Just wait till somebody leaves and you come up there, okay? I don't mind. Don't have me a line because that drives me crazy. Everybody's going to get checked, okay? Is everybody good with that? You have until 8:40. I'm going to give you 15 minutes. We're going to get this process done in probably 15, 20 minutes. At 8:50, the next lesson is real easy. It doesn't take 10 minutes to do it, okay? It's just talking about complex numbers, okay? So it's not overwhelming. So we're going to do this for 15 to 20 minutes, okay? If you finish your checkpoint and you make 100, then you can start working on that second math work, the assignment down there. You know how to do the math workshop. You know how to do page 57. Just start working on your homework till I start back teaching. Is everybody good with that? Checkpoint. You do not talk to your neighbor. You do not look at your neighbor. You can use your notebook. You can only talk to me and the talk to yourself in your mind. When you come up here, I'm going to circle the ones. I don't tell you what you did wrong. You're going to go back and try. It's called productive struggle. Okay? After the second or third time, we're going to put it aside. I'm going to work with you tomorrow on it, okay? But you're going to work for that 100 on it. All right. When you get it, start. Mr. Lamar, start handing them out on the side, please. If you don't have enough room, you can write on the back. This is your first grade, go in the grade book. Oh, and bring your notebook when you come up here, because I want to check to make sure. Some of you I'm missing homework assignments that we had. I'm going to just look for all 3 assignments that you've had so far, okay? So I can give you 3 checks for 100. And remember, it's not a race. You impress me if you get them right, not who finishes first. Make sure, guys, that when you need to check to see if both answers work, okay? Good enough. Thank you. Okay, gotcha. You're good. You're good. Thank you. Open
sign. Did you get all your homework? Okay, thank you. You good. I'm curious, why did you know this out? Now, quadratics, do you have to check that on quadratics? Yeah. You see what I'm saying? Go back and look at that one, and go back and look at that, okay? You have everything? Thank you. Let's see. You got everything here? Great. And I like that MTH. Good job. Got a bunch of checks in here. Bunch of checks in this house. Just 2 times 5. 2 times 5. Check on those pencils. 2 times 5. Plugging it back in. 2 times 5. 10 minus 1 is. Square root of 9 is. Square root of 9 is. 5 minus 2 is. So 3 equals 3. Okay. Now let's do 1. 2 minus 1 is. 2 minus 1 is. Square root of 1 is. So what's 1 minus 2? So just change the curve. Just put it on to it. You got all your homework in there? Right here. Okay. How we're doing, Kyle. Good job. Good job. Okay. I want you to go back and check these. On these work marked on the signature. Okay. Don't erase everything. On this one, let's see here. Look right here. This step right here. Right there, okay? You got everything on your homework? Yes, sir. Okay, let's see your time. Good job, John. Yes, you're good. You got it? Okay, good job, Stephen. Let's see how you're doing. Dylan. You have to see what you did wrong. You just made a little mistake on that third line. You have all your own way. Oh, no, you're good. You're good. Thank you. Just let that one. Hang on. Yes, how you doing? JC, sure. Gotcha. Pretty sure I did number 2 wrong. You look at number 2. You look at number 1. And you need to check that. Don't erase that. Right there. You got 6. So 2 times 4. And need 4x convert to y. You got all your homework. We need to finish up the next 6 minutes.
That was the first day.
That was the first day, yeah.
That was
those last names.
Gotcha.
I'm good at that. Good job, proud of you, buddy. Great job. Good job.
I'll bring that homework up.
Good. Good job. You got all your homework, Jack?
Yeah, do you want me to bring it up here?
I trust you. Good job. I bet you got all your homework. Just flip through it. Let me look at it. Okay, keep it. Yep, flip. Good. Good job. Thank you. Good job. Why don't you check these two? Why don't you just try to see your checks up on that side? Great, too. Good job. Okay, on quadratics, do you ever have to check on quadratic names? That's both those variants, okay?
The only ones you have to check on is rational and what? If you have more than one answer, rational and radical, okay?
I need you to go back and look at that one, okay? You got all your homework, Jay? Okay, keep looking. Good job, you're good. Like, take each one of these parts out. What's 6 times 2? That's me. You got all your homework done? Yep, you're good. Okay, I'll show you. Okay, thank you. Good job, good job, good job. Good job, bud. Okay, first one. Second. Good, thank you, buddy. Good. Get all your homework. Yep, gotcha. Good job, good job, good job, good job. Let's see here. Right, the 6 is canceled, but what's still left here? Okay. Good job, Tom. See what you did here? All right. X minus 5. Okay. How you doing this morning? This is good. This is good. This is good. Good job. I need you to go back and look at. Okay. You got all your homework? Second, I trust you. Right through. Thank you. Gotcha. Well, you need to check if one of those does not work. And you need to go back and look at this right here, because it does factor. Okay, you can get rid of fraction. So what's your common denominator? 6, so it means also this plus this. You got it here. Good job, Mark. You're good. I got you. Just a reinforcer, you have to lose this.
All right, in 3 minutes, we're calling quits. If you don't finish, you come to 0 here tomorrow.
Zach, you got all your homework? Good, thank you. Good job. How was it? Yeah. Good job. Whatever you get was quadratic, but if you don't plug that thing, it's quadratic, okay? I just need you to understand that. You got all your homework to do. Okay. You good? You're all good. Go back and look at that, okay? Well, just leave it up here and we can look at it now, okay? Okay. Which one? One more. Okay, gotcha. Okay. If you had not come up here and show it, then come on, get in line quickly, okay? Yeah, sure. You got everything? Thank you.
Only $2.30.
We need to look at
That's what I want. $2.30.
From the zero here. But just look at it.
I'm gonna go.
I'm gonna see you in zero period. Alright, once again, I'm going to say this, guys. Quadratic equations. Whatever you get, that is your answer. Do you cross any answers out to quadratic equations? No, that's radical or what? Rational.
Rational.
Are we good?
Sir.
I'll see you tomorrow. Zero period.
Change number 2.
Is it? No, I'll see you tomorrow, brother. Show me all your homework.
You send me anymore, so.
Okay. This one's right. This one's right. This one's right. Right, see you tomorrow. See you tomorrow, zero period. Good job. Okay. What's your name? I do think still see all homework. Parker, Derek, do not leave class before I see it. Luke, Jackson, Nolan, and Mason, do not leave class before I see your homework. All right. Now, I said come to zero clear. You don't have to be here right at 7:30, but I need to see you for at least good 15, 20 minutes, okay? Don't let me come punch you down the hallway. All right, here we go. So we're going to turn to our notes. It looks like this, complex numbers. And we're going to talk about complex numbers for a little bit today, just a brief. And if you look at this chart here, guys, complex number. A complex number is the entire thing, okay? The part with the I is called the imaginary part. The part that is not with the I is called the real part. So the whole thing is a complex number made up of a real and an imaginary part, okay? Some people like to call it the whole thing imaginary. No, part of it's imaginary, the whole thing's complex. Does that make sense? Okay, we have two number worlds. We have the real world and the complex world. And we're starting to talk about complex. Alright, so on these first four here, all you're doing is identifying the real and the imaginary, okay? Alright. What will be my real part in number 1? 3. So you're going to put real equals 3. What will be your imaginary? Okay. You just put 4. Even though it's 4i, you just put the coefficient in front of the I. The imaginary is 4, okay? But 4i is the imaginary, but just put 4. You know what? It doesn't bother me. The author's textbook said 4. Let's just put 4i because that's really what it is. Alright, number 2. What's my real? 1/2. My imaginary is what? That's all we're doing here. Number 3. You said, Miss Chester, that's not a complex number. It all has imaginary. Well, it has a real part. What's your real part? 0. So real is 0. Imaginary is 6i. Number 4.
-7. What's my real part? What would be my imaginary? 0. 0 or 0i. I'll just put 0 because it's not there. Okay, let's look at number 5. What would you write for your real part here? 3/4. Very good. Your imaginary would be what? 5/4 I. So the whole thing is called a what? Complex. We're made up of a real and imaginary. In these complex numbers, what do you always put first? The what? Real, if you have it, and then the what? That's standard form, okay? So they're very good with that. So if you ever think about how do I write my answer? Real, then imaginary. Y'all remember doing this last year? Okay. All right, now these, okay. These are what some people don't like, and I found a way to, they're very easy. When I was in high school, I hated this because I couldn't ever figure these out because some teachers taught it by finding a pattern. I don't do by pattern. What do we know this one's equal to? I squared is equal to what? If you know that one, you're good with everything, okay? So I squared is equal to -1. You need to know that. Because the square root of -1 is what? I. That is why I squared is -1. Because they are reciprocal. Squaring something taking the square root. So if you know I squared is equal to -1, you can solve any of these. And this is what I mean by this. Do y'all remember I to the 12th in Algebra 2? So what you do is you start off by writing I squared. Every time you're going to write I squared first. How many times does 2 go into 12?
6.
Okay. Now, you know I squared is equal to what? -1. -1 raised to an even power will be +1 or -1? Your answer is +1. Number 7. I'm going to start with my base I squared. Every time, guys. Because your answer is either going to be 1, -1, I, or -I on these. That's your 4 choices. Okay? Now, how many times does 2 go into 30? 15. You're going to say, Mr. Chester, what if it doesn't go evenly? We're going to look at that situation in just a second, okay? Okay, what is I squared equal to? Okay, -1 raised to the 15th. Will that be +1 or -1? So your answer here is -1. So I to the 30 is equal to -1. I to the 12th equals 1. All right. I to the 55th power. I squared. 2 goes into 55.
27.
We're going to say 27. Because 2 times 27 is 54, isn't it? How many remainders do we have? 1. So I'm going to put that remainder I outside of it. So 2 times 27 gives you 54 with that remainder right there. What is I squared equal to? -1 to the 27. Positive or negative? So then I got -1 times I, which is what? That's my answer to that. So if you know I squared is equal to -1, you can solve any of these. Start off with that base I squared. 2 goes into it how many times? If it goes evenly, it's perfect. But if it doesn't, you put that remainder out there beside it. It's always going to be a remainder 1. See that? All right, let's look at that last one. 107. 2 goes into 107, be 53 times. Because 53 times 2 is 106. I have a remainder of I. What's I squared equal to? -1 to the 53rd power. Positive or -1? -1 times I is? That's your answer. Does that make, do y'all like that method? Because that trying to memorize patterns, I can't do all that. So if you just know that I squared, start off with I squared. That was our whole lesson for today. Wasn't that an easier lesson today? I told you it would be less stress. Yes, buddy. Go ahead, Jack. Yeah, your answer is gonna. Okay, you might want to say, okay, Miss Trish, give me an example when it's gonna be I. I to the 17. Which is I squared. 2 goes in 17 8 times. Negative 1 raised to 8 power is 1. 1 times I is I. So your answer is either going to be I, negative I, 1, or negative 1 on those. Okay? So, like that last, okay, so math workshop you probably should already be done. Page 57 reviews rational and radical. And page 64, that's 7 to 13 odd, that's just saying what's real and imaginary. So it's not a lot, it doesn't take you long to do that, okay? Your hardest part is those 7 equations on page 57, okay? Alright, if I called your name, guys, bring up your homework. Let me see that. All homework since the beginning of last.
Not too bad.
That was the first day with Parker.
Yes.
Okay? I was missing that, okay? Keep going. Okay. You're good, y'all caught up. Okay. Okay. I think I've seen your check when I said, yeah, because you did that senior meeting, that's what I was missing. And that's what no from last night, that's what I'm missing. Hey, good, thank you, bud. All right, Mr. Lamar, you all called up. See you in the morning. That's the one you're missing, so you're good. And you did last night?
See, that's the one at home because I was confused with which number.
Okay, you need to do it by Thursday for your notebook with Jackson. You're good, okay?
All right. So y'all see how checkpoints work in my room? We good? And the ones coming in the morning, that's just for us to, you're going to start over and let me watch you what you're doing on these problems. I'm going to say, I'm going to question you. I'm going to give you an answer. I'm going to ask you, why do you do that? Why aren't you think about this like this? You have to work for that 100. Y'all have a great day. Tomorrow we're doing adding, subtracting, multiplying, dividing complex numbers. That wasn't too bad today, was it? Wasn't too bad. It was not too fast today, was it?
I even had a cup of coffee this morning. I'm so ready to pass out. I'm like, going home.